We're going to talk to you about how we measure single-page applications, the performance of single-page applications using Boomerang. The talk is, well, I call it room service and spas. Any Swedes in the room? So there was an article written about the Boomerang rum product, except the word room, R-U-M, in Swedish translates to room, right? And so we basically became a room service provider. And then we decided to go into spas as well. So now we're offering both room service and spas. You want to?
Sure. Yeah, I'll take it off. So we know this is the last talk of the day, and we're going to be very respectful of your time. We do have drink tickets if people ask us questions at the end. So feel free to come up afterward. We do have slides up right now if you guys want to follow along. SlideShare/Nick Jansma or at Nick J Twitter handle. You can get those slides right now, and obviously they'll be available afterward.
Yeah, the colors of the slides are going to be different because I changed them while I was sitting down here.
Okay, so we're going to talk about measuring single-page apps today, but we want to start out with a little base of some definitions just to make sure we're clear about everything. So we're going to start out with RUM. I'm sure most of you guys here know what RUM is, but just to be clear, so RUM is real user measuring the performance of your page in the wild, of page loads. And this can be compared to synthetic monitoring, right? So synthetic monitoring is emulated users in a controlled environment. How is RUM done today? Well, for what we do, we have Boomerang, which is a JavaScript snippet. It's in our customers' pages. And Boomerang listens for a lot of things. It listens for the ready state changes. It listens for the onload event. And it uses these to measure the performance of your page loads. It can also gather a lot of interesting metrics like DNS and TCP time, SSL time. And it gathers this from navigation timing if it's available in the browser, and other important events like user timing metrics. And finally, a RUM tool needs to capture characteristics of the page load, like what user agent it is, what screen size they're at, and stuff like that. And then after it gathers all this data, it beacons it back to a server, so you can use it for analytics. Navigation timing, which you've probably heard of, window.performance.timing gives you statistics measured in microseconds about the page load, so for DNS and TCP and everything. And a lot of RUM is built on top of navigation timing. Navigation timing, thankfully, is very well supported in today's browsers, and I'm very excited that iOS 9 actually has it in now. So we have really good performance metrics on mobile finally. Resource timing is pretty similar to navigation timing, except for where navigation timing is focused on the timings of your page load experience. Resource timing is about all the resources on your page. So you get the same breakdown, DNS and TCP, request and response, for all of the images and XHRS and CSS on the page. And with resource timing, you can basically reconstruct a waterfall, a browser waterfall that you would get from a developer toolbar. Resource timing isn't as well supported as navigation timing, only about 55% of the browser market share. And hopefully we'll get resource timing in iOS by like iOS 15 or something like that.
We'll get it in BlackBerry first, I think.
So as Steve said, we build our product on top of Boomerang. Boomerang's an open source project created by this guy when he was at Yahoo. Boomerang gathers all these performance characteristics that I talked about. We do contribute to it, but you can check out the source on GitHub. And today's topic's about single-page app, SPAs, as we like to call them. And the difference is with a single-page app is every single interaction you have with the app stays on the one page load. The app framework itself dynamically brings in content and swaps it out from the old content.
So how many people here have or own a single-page application? All right.
Quite a lot. Yeah, and it's growing too. I mean, most new apps seem to be built in things like Angular and Ember and Backbone and stuff like that.
How many people use a framework? And all right. And what about using just raw XML HTTP request? Awesome.
Few. And one important term to delineate how you navigate in a single-page app. So there's soft navigations and there's hard navigations. So a hard navigation is like a traditional website. When you navigate to the page, you're loading all the static content that's on the page. You're loading the HTML and the JavaScript. In a single-page app world, a hard navigation is the very first page load. You're also loading the framework, so like Angular.js itself. And then Angular goes and picks out what view you're going to look at, renders the view, gives it to the browser goes to fetch all the resources and everything. So the very first visit in a single-page app world is your hard navigation. That's opposed to a soft navigation. So once you're in the app, a soft navigation is all your other interactions within the page. Your URL might be changing because the app framework itself can change the URL without actually causing the browser to navigate. But by that time, all the framework's been loaded. You don't have to refetch Angular.js. You don't have to refetch all your JavaScript and CSS. And so they're very important to understand the difference between the two.
Right. And hard navigations are very susceptible to a cold cache case as well, because you do have to pull everything over the network, versus soft navigation where pretty much everything's already in the browser.
And in most frameworks, every page that you can go to can be either a hard or soft navigation. So if you're coming from Google to your product page, that's a hard navigation to it. But if the user's already on your site on the home page and then clicks to the same product page, that could be a soft navigation. So the performance characteristics will be different depending on whether it's a hard or soft navigation because of all the additional content that the hard navigation requires. So today we're talking about measuring these single page apps, and there's a lot of challenges to it. Challenge number one is that the onload event doesn't matter anymore. So for a traditional page, a traditional website, on navigation, the browser is downloading all the resources, downloading all the CSS and JavaScript, static resources. And once all that content gets fetched, the body's onload event fires. This is traditionally where people that are doing RUM measure the onload for the page, how long it took to load the page. And this is where RUM tools traditionally hook into to say when the page is complete. This is an example waterfall from web page test. This is just my personal website. The blue line on the far right hand where I'd say page load complete, that's when the onload event fired. That's when all the static content on the page was loaded. And this is what a traditional RUM tool for a traditional website would measure. The problem for single page apps is that they behave a little bit differently. So all the static content in a single page app, so your core JavaScript, CSS, and your Angular framework, for example, like Angular.js, that's all included on the page statically. And the onload event will fire when that has loaded, not when the view has rendered. So it takes, as soon as Angular comes in, the onload fires, and then Angular decides what it's going to display. So like it decides based on what URL you're on, what content it's going to render, what page you're going to look at.
Was anyone in Steve's talk yesterday? Yeah. So I think he spoke about some of this where onload doesn't really matter because there's almost nothing on the page in some cases.
And it's after the onload that the framework kicks in and tells the browser to go fetch all the additional resources required for the actual view you're looking at. So this is the example Angular app on the GitHub website. To the left of the blue line is all the static content on the page. So this is all the JavaScript and the CSS and AngularJS itself. You can actually see Angular in the list if you squint hard enough. The blue lines where the onload event fires. And all the content to the right of it is all the actual images. So this example page, I think, shows a list of phones, phone models and phones. And the onload event you can see is firing basically in the middle of the page before most of the content's complete. We use web page test to get that waterfall, and actually web page test provides a film strip as well. If you look at the film strip at the bottom, the first two panes are from 0 seconds to 1.6 seconds, and it's white. There's nothing at all. Yet we said the onload was at 1.2 seconds, right in the middle of that. So the onload from the browser's point of view was when there was nothing on the page. All the visual resources happened to the right of the line. Content didn't start coming in until about 1.7 seconds, 1.8 seconds. That's when images started getting fetched. And it was fully loaded. All the content actually didn't come in until about 2.2 seconds. So the onload event was very, very off from what the actual page load experience would be from the user's point of view. So yeah, so that's the main challenge number one, is that the core problem is that all the images and JavaScript, HTML templates, all that stuff generally fetched after the page load, after the onload event. And the browser doesn't fire any more onloads. It only fires it once. It doesn't fire any sort of fully loaded event or anything like that.
Loaded some more. We need an on-loaded some more event.
The second challenge for measuring single-page apps is that soft navigations are not real navigations from the browser's point of view. So on every route change, user interaction, et cetera, dynamic content is pulled from the server, from templates within the browser, and a new view is rendered. The application itself can fake URL changes in the address bar without actually navigating the browser. So it can just keep on saying the URL is changing every second. And the new content is swapped in over the old. This is great for performance. The browser is no longer tearing down the old page. It's no longer re-rendering the header and the footer, no longer reparsing JavaScript and CSS and all that kind of stuff. So great for performance, but bad for us. The problem is that traditional RUM tools stop caring after the onload event fires. Traditional RUM tools won't run again because the page load has happened. And browser events like ready state and onload and even navigation timing are all geared towards this one page load, quote unquote, that will ever happen. And in a single page app, you're going to have more than one page load occur because the user is going to be clicking around. So the third challenge out of 3 is that the browser won't tell you when all resources have been downloaded. In a traditional website, the onload event fires when all the statically included content has been loaded, as we've said. And this helps us know when the page is mostly complete. In a soft navigation scenario, so when you're navigating between pages on your site, the onload event's never going to fire again. So we have no idea when all the next set of content has been downloaded.
So quick question, how many people, when you build a single page app, do you change the URL, like using the history API? All right, it's pretty good. We'll get to that.
And soft navigations can fetch a lot of things. And all these things are very important for visually completing the visual look of the page. So a SPA app may fetch new HTML templates. It may go get XHR to understand what to draw. It may go get more images or videos. And all that content is very important to the end visual result of the page. Now, some of the SPA frameworks, like Angular, for example, they fire some events around when the route has changed, when the URL is changing. But they're not exactly relevant to the old onload event that we love. So route change start, for example, from Angular is fired whenever the route's going to change, whenever the URL has changed, whenever the user's clicking on something. And view content loaded sounds like it's exactly what we want, but it's actually a different event. It's emitted when the route has changed and Angular has injected the templates that it had rendered into the DOM. But it has nothing to do with all the activity that the browser then does afterward. When Angular shoves in all its new HTML into the DOM, the browser has to go and look at all the images, all the videos, all the CSS and JavaScript included in that HTML, go fetch it, go render it, go display it. And so it's at a completely different timeline. Yeah, this is basically just a visual diagram. The user clicks.
The browser's disappeared.
Oh, yeah. Angular has to decide what to display. It fires the route change start to say it's about to change the view. HTML templates are possibly fetched via XHR. It hands that off to the rendering engine for like Angular, the templating engine. At this point, Angular says, OK, view content's loaded, and then hands it all off to the browser. Unfortunately, that's the point that the browser has to do the heavy lifting and go to the network and fetch everything that's important. This is the same timeline that we saw before, the same waterfall, the sample Angular app. So the route change start when the route is when the content's actually gonna be shown is when the onload event happens, and that's when Angular loaded. View content loaded is just a couple 100 milliseconds later. That's when he put all the template that he rendered for all the phones in this example into the DOM. And that's still only at 1.4 seconds. But remember, we don't actually see anything from the filter strip point of view until 1.6, 1.7 seconds when images start coming in and stuff like that. So even the events from the frameworks themselves are not very indicative of what the actual performance is. So those are the main challenges of SPAs.
Right. So what we need to do is really detect when has the user, right? We really care about perceived performance, and we care about when the user has indicated that they want to do something, change the route in our case. And then finally, when has the framework or when has the application, when has the browser completed doing that thing for the user? So when is the end event? When is everything now available for the user to start using it? And how do we actually go about figuring that out? So for hard navigations, it was pretty easy, right? When the user clicks on something or types in a URL, that's essentially when the user has indicated they want to start doing something. With navigation timing, that's indicated with the navigation start timer. Browsers that don't support navigation timing, which luckily today there are less than 1% of. We could do other things like saving a timer in a cookie. The traditional RUM method that's worked for us the last, how long has it been, Steve? 10 years? Yeah. So there are ways with hard navigations to detect when things have started. With soft navigations, it becomes a little more complicated, but still you can detect when the user has done something, right? You can set a click handler on the page. You can look at the change of the history using history.popstate. You can look at various events you can find out whether an XHR has been initiated or something like that. So the various events you can use. But again, soft navigations are not real navigations, right? There's things that are changing. Some of it may require the network, some of it may just require rendering. Maybe you actually have all the content loaded but invisible, and the user does something and just make it visible, right? That's still a user interaction that you want to measure and find out how long did it take, right? So there are various things that may not always result in a network, but you want to detect that start. So we typically say, has the user clicked on something, or has history changed, or have they interacted with the keyboard? Window.history can tell us when the URL has changed. So if you're a well-behaved framework, and there are many of them, but there are also frameworks that are not well-behaved. But if you are, you use the push state or replace state to change the URL without actually causing a navigation in the browser. If the user hits the back button, then a window.pop state event is fired. So we can actually override push state by with JavaScript. JavaScript's pretty cool. You can override anything. You can even override the stuff that's overriding something. And we spoke about some of this in our tutorial on Monday, but so I'm not going to go into a 90-minute talk about that. But essentially, because it's so cool, you can hijack things like push state or replace state and figure out when a framework has tried to change the URL and say this is probably a start event. In the case of pop state, you don't need to hijack anything. It's a standard browser event, so you can just subscribe to it just like all the other event subscribers. And future events coming along. What future events are those?
Clicks and XHRs.
Clicks, right. Clicks, XHRs, etc. that happen after the history push state will tell us more. So in the case of actual frameworks, and we've looked at 3 frameworks. My favorite is not here. It's called Massage Envy. It's a great spa. AngularJS has the route change start event. So whenever the user starts or indicates to the framework that they want to fetch some new content, a route change start event is fired. This is an AngularJS event, not a DOM custom event. So you can't just do a window.add event list. Now you have to use $rootScope.on $root change. Why are there so many dollars? Right? It makes me feel like writing Perl. Ember.js, there's other events, and with Backbone as well, you can do router.on route. And you can subscribe to these events, say, this is when my timer starts, so all you need to do is really start a timer. Now, that's really not enough, because like Nick already said, the end event doesn't really fire when the framework says it has. Something else we can look at is click. So if the user clicks on something interesting, typically the user clicks on a link, and if you have progressively enhanced that link to then go ahead and fetch content or fire something on your framework, you can track that. So you may want to listen to clicks on every link. What we do actually is listen to clicks on the document itself and use event delegation to detect if it was something interesting. How we define interesting is not actually by what they clicked on, but what happened after they clicked. So if they clicked on something and network activity happened soon after that, or the DOM started changing soon after that, that means it was interesting enough to actually record that time. If nothing happened, maybe they just accidentally clicked on white space, right? So nothing happened.
Selecting text or something like that.
Yeah, or maybe they selected text. Maybe they were pointing at something to a colleague. So there are various things a user can do that may look interesting but aren't really. So you want to see what happens next to find out if it was interesting. XML HTTP request. There are also cases where the user may not have directly interacted with the page, but that did fire something off on the network. So for example, let's say you have infinite scroll. Who has infinite scroll? All right. I hate infinite scroll. But let's say you do have infinite scroll, right? And the user scrolled to the bottom of the page, right? You fire off a new XHR request at that point. So you typically don't want to capture every single scroll event, because that might be just too many events. Not enough of them are interesting. But you can track the XHR that's going out and fetching more content over the network. So you can say, this was something interesting, and XHR happened, and content came through. I'm going to start timing when that XHR goes out. But not all XHRs are interesting, right? The user could be, for example, typing something in a search bar, and you're trying to autocomplete that. Do you actually want to measure how long it took for every single key press to result in updating that autocomplete? Maybe not. It could also be polling. So many apps will poll their server every 30 seconds or every minute to say, I'm still alive, I'm still alive, I'm still alive, right? And you don't want to do that. You don't want to measure every one of them because they're not interesting to the user. They're not telling you anything about the user experience. It's sort of your app being convenient to itself. So what we can do is whenever we listen to a click or an XHR, whenever we see that thing starting, what we'll do is then wait for a little while. What is it now, 100 milliseconds? So we wait for about 100 milliseconds to see if something changed. What do we mean by something changed? Well, what are the other network requests? So in the case of a click, did it result in an XML HTTP request after about 100 milliseconds? In the case of an XHR, well, if it's an XHR, we know there was network activity. But what else could have happened? Could the DOM have changed? So looking at the DOM, see if there were new nodes added, were there new images added? If there were new images added, add event listeners to those images to see when those images finished loading. If there were new links added, if the history changed. A lot of things can happen when you click, and all of those might be interesting, saying that we are actually changing the page in reaction to what the user did. So let's go and start listening to all of those. And if nothing happens after 100 milliseconds, it's probably a false start. So we'll just clear the slate and say, let's wait for the next one. If another click happens while that thing is happening, we'll just reset the timer to that new click because maybe the old click was false, but the new click is not false, right? So we figured out where to start, right? There's a SPA route change or a user click or XHR or some other interaction. Like I like to play with my leap motion, so I can do stuff with my leap motion. I may not be touching it, but I'm actually firing events, and I could listen to those events as well, or XHR activity, right? But how do you tell the end? Right? So when do we actually consider that complete? Well, we could say when all networking is complete, but how do we know when all networking is completed, right? We know kind of when the XHR started or when the user clicked, but like we've said earlier, you load up the entire template, you put that into the DOM, and after that, the browser decides, hey, there's new DOM nodes, there's new images added, there's new scripts added, I need to go on the network and fetch those. Because of the way JavaScript runs, it's single-threaded. So after you put those things into the DOM, it doesn't happen immediately within that function call. It's when control returns to the browser's main thread, that's when the browser goes ahead and downloads it. So you are no longer in control, right? Your JavaScript's no longer in control when the browser's downloading things. So what we try to figure out is, well, has something interesting in the page changed, and what is that? Traditionally, we would measure up to the onload, but now we have many onloads, right? We have the XHR's onload. If any content was added to the page, we have the onload event for all of those network resources like images. You can attach an onload and an on-error event to that. You can do that for links. You can do that for scripts. You can do that for iframes as well. So anything that actually needs to request content over the network typically does have an onload event. The big exception is fonts. You cannot attach and background images, right? So if you actually add a new CSS file and that happens to have a background image or a font in it, you would not be able to attach an onload event to those particular resources, but pretty much anything else. So we get pretty close. We don't, not in all cases will we measure everything. What we really wanted to know was, for all these things we are measuring, which of them can be single points of failure? Because that actually causes a different problem. If a resource that's been, that we initiated the download for does not actually complete, right? What does that mean? Right? It might time out, which means we would never get a complete event. What will the browser do in that case? It'll just show, if it's an image, it'll just show that little broken image thing, and then it'll continue. But we won't know because we don't know that's happened. If it's a JavaScript or something that's not downloaded, maybe the page won't actually work after that. But we still want to know something has ended, so we'll attach to both the onload and the on-error. But we'll also need to set something like a timeout, so do a set timeout of, how long do we set it for, 5 seconds or something like that. A reasonable amount of time that we know, okay, if it doesn't happen, then we'll just say this particular event that we started is not ever going to end. So let's just send a bot a response back to our server and say, something went wrong here, go investigate it later. Right? So actually, we already spoke about all of this. We could look at resource timing as well, right? Every time you add an image or a script or a link to the page, you should get resource timing information back from it, at least from browsers that do support it. The main problem is we don't know if there are outstanding resources, because resource timing only actually shows up, resources show up in resource timing only after they have completed loading. So you get nothing when something is started. You only get information after it's completed. And if it never completes, it actually never shows up in resource timing. So any resources that error out because of 404s or TCP error, DNS error will never show up in resource timing. And that is a bit of a problem for us. So measure everything and invent our own single page app onload event that basically is when was the last of the onload or on errors or timeouts of all of these resources. Let's fire an onload at that particular time. And that actually gives us an interesting side effect. So how do we go about monitoring these XHRs? Well, XHR is pretty simple because it's a JavaScript object. You can just hijack it, provide your own XML HTTP request object that calls out to the main one, and then override .open and .send, set a bunch of timers in each of those, and then you can subscribe to the loaded event, right? Is that it? And fire things at that point.
And look at the ready state as well to get when the bytes first come in, when the bytes end up coming in, and all that kind of stuff. Yeah,
the pretty cool thing about XHR is even before resource timing, there were a lot of different states on the XHR object, like load started. So when the HTTP headers started coming through, you'd get an event. When content started coming through, you'd get an event. When the content completed, you'd get an event. So you can sort of fake resource timing on XHRs just by looking for these different events. Right? There is, all of the code is here. It's rather large for a single slide. So what we're going to show you is just simplified code. Essentially, right at the top, we're overriding the XML HTTP request with our own function. So whenever anything on the page, which would be jQuery or AngularJS or your code itself calls XML HTTP request, they end up calling our code. What our code does is add our own event listeners to that, to the XHR, override the send and open methods, and then return the original XHR object back to the caller. So the caller is actually still interacting with the browser's XHR object after this point. It's just that we've got the chance to set a start timer and intercept all of the events in between. Right? So you can know which URLs are being fetched because whenever the user calls requested open, they actually pass in the URL. So you know the URL. You know whether it's going to be a get or a post. You know when it's completed because of all the event states that are going to fire. And you know if there are outstanding requests. So unlike resource timing, you know when a request has started, and it doesn't matter if it doesn't end. You can figure that out later. You need additional code to handle cross-domain requests, which we're not going to go into because we don't actually do that in Boomerang. Right? We took the call early on not to support cross-domain requests, which is really Internet Explorer 8 only. Instead, we said if you are newer than that and you support CARS headers on your server, we'll just get everything we need from there. Right. So timing is not as accurate. If the browser's too busy, it won't be the same as resource timing. You might be like a second off, which is not good, but it's the best we can do. And you can fix it up with resource timing. So what we do is if a browser does support resource timing, we just override the timings with that. For other resources, you could override, for example, the image object, but that doesn't work unless all your images are created using JavaScript, which who creates all their images using JavaScript? Awesome. Who creates all their JavaScript using JavaScript? That's actually a performance enhancement if you... Right. So it would have been great if we could tell if these things were loaded, and it so happens there is an API that supports that. The mutation observer. Do you want to take over mutation observer?
Yeah, so Mutation Observer lets you get notified of important DOM changes. So we start a Mutation Observer after one of those important start events, so like an Angular route change or a click or something like that. And we're waiting to see all the HTML that's getting inserted to the DOM at that point. Now, the benefit of it is it's pretty lightweight. There was a mutation events beforehand, and that was really heavy and really bad performance. Mutation Observer delivers the new nodes that are being inserted into the DOM in batches, so you can analyze them in a much more performant way. And we can also set filters for what we're actually interested in. So in this case, we're interested basically in elements that get inserted, they're children, but only if they have a source or href attribute associated with them or being changed. So that basically gives us access to images, to link, to script tags, to iframes. And then that way we can actually attach these load events and error events to all these elements that are getting inserted. So again, this is more simplified code. This is the callback that we would get from a mutation observer. We end up looking at all of the mutations, and for all those mutations, we look at all the nodes that got inserted. And then we individually inspect all these nodes to see if it's an image that we care about, or not an external JavaScript, but not an internal inline JavaScript, for example. And at the end of the day, if any of these are interesting, we will hold the navigation until all of these resources have been fetched.
Yeah, there was this interesting time when we waited forever for a data URI to load.
Yeah, so here's the workflow. I basically just described it, but we start a mutation observer, we wait for all the changes in the DOM, we look at all these changes and see if they're interesting, see if we think they're going to kick off an external resource, attach all of our loaded and error events to all these resources, and then we wait for them all to complete. And once the last one's done, that's the end of the navigation. That's basically what the onload event in a statically, like a traditional website would fire. You don't want to look at all resources. For example, images that don't have, or that come in with a natural width set, mean that the browser already had that image ahead of time, and it's just going to redisplay the image. It's not going to go to the network to fetch it. Script elements that don't have a source, like they're inline scripts, you don't want to wait on them, because obviously they're inline. Iframes with the JavaScript or about protocol. There's subsets of these elements that could be external but may not be, and you don't want to wait for all of them. The downsides is Mutation Observer isn't 100% support. I think it's 83% of the market supports it today. It can't be used to monitor everything. So as Philip said before, CSS with background images or fonts, you can't actually hook into onload events of those. You won't get notified of them. There are some polyfills that can, for the browsers that didn't support it, that you can use to actually get a Mutation Observer like callback when new DOM elements come in. There's going to be some performance implications there, but if you need to support, I think, IE9 and lower, no, sorry, IE10 and lower, you could use one of these polyfills.
Is that a question or 5 minutes?
Is 83% weighted by users or just browser UA?
This is by users.
Yeah, global market share.
So we highly do not recommend using the polyfills for Mutation Observer unless you absolutely have to. They will cause performance problems.
And why are we doing this and not resource timing? As Philip said before, resource timing doesn't tell you when something started. So we have to know if there's anything outstanding on the network, and we can't know that from resource timing. The other interesting thing you could do with Mutation Observer is you could actually polyfill, in a way, resource timing. So you're actually hooking into all these external resources. You're knowing when they start and you're knowing when they end. You could actually build a waterfall out of Mutation Observer for clients that don't support resource timing. The interesting intersection there of people that, or browsers that support Mutation Observer and not resource timing is iOS or Safari.
So imagine having resource timing on iOS before navigation timing.
And you actually could with iOS 8. Yeah, so that's how we're measuring all the components on the page, and that's how we're defining the end event for all these scenarios, and how we're measuring a single page app page load. A little bit more details. So in a traditional website, you have front end and back end time. That's how you're breaking down your entire page load. With a traditional website, the back end time is when you're starting to fetch the HTML up until when the first bytes come in. That's all the time you're waiting on servers. Front end time is everything else. So it's the browser parsing the DOM, inserting images, et cetera. We've picked a similar definition of backend time for single-page apps. It depends on your scenario, but one way that we like thinking of back in time for a single page app navigation is any time that you have an XHR outstanding, the intersection of that time. Because we think in general, XHR is a very critical component to loading your apps. You can't build your view unless you have the data that you want for your view or the templates that you need to fetch via XHRs. And so our definition of back in time for a single page app is any time where an XHR is outstanding. And then front end times remains the same. It's just the total time minus the back end time. I'm going to skip this, but please check the slides later just because we're running out of time. The other very important aspect of single-page apps is the life cycle. What happens over time? You know, with a traditional website, every time you're navigating, you're building a new page, you're building a new page, you're building a new page, you're starting fresh. With a single-page app, you're not. You're collecting all the cruft over time. And so it's very important to track a lot of these things over time and see how your app's behaving. You can track metrics that highlight performance or reliability or resource issues. Some of the things that we're measuring in Boomerang today that we can track over time are memory usage for browsers that support it, like Chrome, DOM length for your DOM nodes, just as a simple example of complexity of the page, JavaScript errors. You could do bytes fetched if you're looking at the XHRs, and hopefully in resource timing too, once we actually get the payload size, you can actually measure your page weight based on how many bytes you're fetching from the network. And you can measure things like frame rate. And so everything we described sounds like a lot of work, right? Like there's a lot of hoops that we had to jump through just to get some of this data. So thankfully, there are actually some specs out there that might make this a little bit easier and more performant in the future. There's a fetch standard that's being worked on right now. And part of that, there's a proposal for a fetch observer. And that's basically going to give us that start event. So what you can do is you can register for, tell me whenever a new fetch is going to start, no matter where it is. And you'll get this event, and then so you know when there's anything outstanding on the network, you can hook into it and hook in your onload events at that point, and the fetch standard will be like resource timing, and it'll tell you when the fetch is ended as well. The benefit of this over Mutation Observer, it tells you about all the elements that are fetched externally, like CSS background images and fonts. And so you get more visibility and hopefully in a more performant way, so I have high hopes that we'll actually be able to evolve that into something that we want. So that's our deck. We did put a lot of this and more into an ebook, sosta.io/SPA perf book. We'll say thanks.
It is free. Yeah, thank you.
Free drink tickets if anybody has questions.
Yes. We have time for a few questions and we can hang around later. Yeah.
So you mentioned that there's timing for backend from when you make a request to when you get it back. Is there any way to distinguish between what's cached, like is the response still made, versus what went back to the order?
So I'll just repeat the question. We can tell backend versus frontend, but is there a way to tell if the response was cached and was just getting loaded from cache versus getting loaded over the network? So using navigation timing, now there'll be two. There's either resources being cached or the whole page being cached. So in either case, you could use resource timing and navigation timing to find out how much network time there was, so between navigation start or request start and a response start. And typically what we look at is less than 40, was it 40 or 10 milliseconds?
10 milliseconds right now.
10 milliseconds means it's actually going to go over the network. And that's typically based on heuristics. We found that a typical home grade modem adds about 12 milliseconds of latency. So if it's in that order, if it's going beyond that, it's definitely going over the network. Beyond that, it's kind of hard to tell whether they're hitting a CDN and just getting it off the CDN or going to origin. You could use your own heuristics for your case. So we would recommend things like 40 milliseconds as a good within the city limits versus going outside your city. Just take speed of light and multiply it by 4 for the distance. Other questions? Yeah.
You mentioned two events, the start and the end. Is there any way to measure rendering or like visual changes or somehow understand?
That was actually what that was actually the slides that I skipped right now. It's very hard to measure from the browser's point of view.
Repeat the question first.
Oh, sorry. We talked about fetching everything from the network, but can you also measure the browser's work that has to be done after getting this? So like rendering and layout and all that kind of stuff. You can't directly. The browsers today don't actually expose a lot of those details for the script. What you can do is you can measure things around it, for example. One technique that we like to do is after we insert the HTML into the DOM, you just set a set timeout of 0 or set immediate. Hopefully the browser will go and do its thing and then do your callback. So you get something close to how long it took for the browser to actually process it. It may even not be exact, maybe there's a couple threads working on what's going on, but at least you're not blind to that kind of stuff. So you at least kind of get an indication of the work. Free drink tickets. Go ahead.
Why is it critical to get the event at real time rather than just collect it afterwards using resource timing?
Right, so the problem with that is, so the question was, why is it critical to get the event in real time to know when it ended versus just waiting for resource timing? The problem with resource timing is you don't know that there's an outstanding, if there is an outstanding thing on the network. So you could be waiting and waiting and waiting and waiting and waiting, but there's actually nothing there. Or there could be something that's going to take 30 seconds to load. That lack of visibility means you could just wait forever. You could wait until the browser's going to unload, but that's very unreliable. And for example, iOS doesn't fire unload events in many cases.
And we still have cases where, for example, a script is already cached, so it doesn't actually fire any events. So you know that it's been requested. It's not in resource timing, let's say, because resource timing is not supported. But there's also no events fired. So you need to go and check the DOM to see whether that thing has already been loaded before the request started.
That's where things like the fetch protocol would help, or
So
protocols will help them.
to know when to beacon.
Yeah, when to beacon. Yep.
So
Yep.
there was a question there.
Yeah, there's two questions. So you had all these events, and we're listening to all these things. Do you have any tools that you guys like to use to, look at this information and analyze it? Or is it just all this streaming data and exhausted data? And kind of on the same thing, at some point, if you added so many things that you're listening to, that you start to performance.
So I'll repeat the question. We're collecting all of this data. Do we have any tools that we use to analyze it? And at some point, does the measurement itself affect performance? Those are the two questions, right? So we happen to build a tool that does analysis of this data. It's called MPulse, and we use it extensively. Sosta.com/mpulse. There are also other tools you could use. So there's an open source server called Boomcatch that collects Boomerang data. And you could then throw the data into Graphite and chart it there. Some people have blogged about using Boomerang with Google Analytics or with Piwik. Somebody else has actually sent Boomerang data directly into CouchDB just by using their REST API. So there are various things you could do. We, in particular, prefer our solution that we built specifically for this. In terms of affecting performance, we have actually done a lot of work to make sure we don't affect performance or we have the least footprint. So one of the things is our script loader. The way we load Boomerang onto the page is non-blocking and asynchronous. It gets out of the critical path. So even if we don't load, if there's a server problem on our end, we won't affect your page performance. Everything we do is we tend to do it when the user's not doing anything. So we measure after onload fires. We beacon back things after network has happened. So we don't contend with with the page for network activity. Right?
We've also looked at the overhead of instrumenting the XML HTTP request object and using Mutation Observer. And generally, we don't even see that stack in profiles when we're doing page loads. Or if it is, it's just a couple milliseconds here or there.
So does Mutation Observer, by its name, provide you an observable where you can kind of do like RX type event chaining?
Not entirely.
So the question is, does Mutation Observer provide you with an observable, so the standard JavaScript library type observable? The answer is not exactly. It returns an observer object, but all it does is it fires events when something happens. So when the DOM has changed. So you can't really chain events and stuff like that. It calls your event handler when it's done.
It's mainly used to unregister itself later.
Yeah. Go ahead,
Steve.
So
I'm going to give out a
where's-
drink.
Oh, okay. So where's the social reception?
I don't know. Where is it?
Mercury Ballroom, but I actually got the form.
Mercury Ballroom.
What floor is it on?
Mercury Ballroom.
I think Mercury Ballroom is on third floor.
Third floor.
There was one question there. So we don't want to hold up anyone, but I know we love these questions. So if you want to stick around and keep talking to us, please do. Yeah.
You mentioned
that you might want to declare something an event when the application is interactive.
Yep.
How do you find that?
Well, you could listen to things. Oh, so the question was, you might want to declare the end of the navigation when the app is interactive, and how can you do that? You could do similar things like just listening for clicks. As soon as you actually get a click event, that means the app has been interacted with. It's very hard to say when it can be interacted with. I mean, that's very similar to like the onload event, for example, when all the resources have been fetched. But the browser may still be, I mean, you could be locked in a JavaScript loop and not actually be able to be interacted with at that point. It's very hard to say when you can be interacted with versus when you have been interacted with. Yeah, so Charlie's saying you could actually listen to the mouse move event, which might help you give an indicator that your JavaScript is processing and that other events are handling. So that might be a good thing to hook into, just on the body.
Hello. Hey, so we should wrap up. If you still want to talk, these guys are going to stay here for an hour. You can take their drink tickets. Just come on up and ask questions. Thanks for coming to Velocity. We'll see you in 2 weeks in Amsterdam.